Dear students, welcome to another chemistry virtual video on the chapter Mixtures and Solutions. Today's lesson title is Factors Affecting Solvation, Part 1. The learning outcome for both Part 1 and Part 2 is to explore the effects of changes in the different reaction parameters on the solubility of solid, liquid, and gas substances in different solvents. Let's begin our lesson with these 2 cups of coffee. So which one do you think will dissolve faster? Granulated sugar, as in this image, or sugar cubes, as in this image? You can try it at home, but make sure that it is the same coffee with the same temperature. So here's our main idea. Factors such as temperature, pressure, and polarity affect the formation of solutions. There are 3 important keywords for this first part and another 2 important keywords in the second part. So let's begin with solvation. Solvation is the process of surrounding solute particles with solvent particles to form a solution. We also have unsaturated solution. It's a solution that contains less dissolved solute for a given temperature and pressure than a saturated solution. In other words, more solute can be dissolved in an unsaturated solution. We also have saturated solution. It's a solution that contains the maximum amount of dissolved solute for a given amount of solvent at a specific temperature and pressure. We also have supersaturated solution and Henry's law, which we are going to cover in part 2 of the lesson. We will begin with solvation part 1. In this lesson, we are going to cover solvation, its process, and the factors affecting it. We'll begin with the process of the solvation of ionic compounds in aqueous solution, molecular compounds in aqueous solutions, and we will discuss factors such as agitation, surface area, and temperature, which all of them affect the rate of solvation. We will also cover the concept of solubility along with the definitions of saturated and unsaturated solutions. As we have covered previously in the keywords section, solvation is the process of surrounding solute particles with solvent particles to form a solution. And when solvation occurs in water, it is called hydration. The solvation of NaCl in water is called hydration of NaCl. But how does the surrounding occur in the atomic level? Let's watch this simulation here for the solvation of NaCl in water. So we will put NaCl in water and let's see what will happen. See, it will dissociate, the ions will dissociate into the positive sodium and the negative chloride. Water molecules are surrounding both, as seen in this image here. So that's why the dissolution occurs or the solvation occurs, because the polarity or the nature of the water molecules. Even if we try to move them apart, they will be surrounded by water molecules and dissociated. Water is a very good solvent not only for ionic compounds like NaCl in the last slide, but also for many molecular or covalent compounds. Like dissolves like is the general rule for solvation of molecular compounds. So now, based on that, if you know that water is a polar compound, what do you think about sugar? Is it polar or non-polar? Let's watch this video to know.
Most substances made up of polar molecules are soluble in water. During this process, water molecules interact with the polar molecules of the solid by electrostatic forces. They remove molecules from the crystal and mix with them, thus dissolving the solid. Sucrose, that is the common sugar we use for sweetening, consists of polar molecules. These molecules contain a number of hydroxyl groups. As sucrose dissolves, water molecules form hydrogen bonds with the hydroxyl groups, pulling sugar molecules out of the crystal structure and transferring them into the liquid phase.
Alright, so the answer is that sugar is a polar compound. So far, we have learned how solvation occurs in ionic compounds and molecular compounds. But how can we increase the collision rate between the solvent and the solute? In other words, how can we increase the rate of solvation? And what are the factors that affect solvation? Let's watch this video and figure it out together.
Solubility is a measure of how well a solute can dissolve in a solvent at a given temperature. Temperature plays a key role in solubility. For example, sugar dissolves much more readily in hot tea than in iced tea. Quite often, when making foods such as candy or fudge, it's necessary to heat the mixture so that sugar can be dissolved. Several factors affect how quickly a substance is dissolved in a liquid solvent. Perhaps you've noticed someone stirring sugar into a drink. Stirring and shaking increases the rate of dissolving. Crushing a solute also helps accelerate dissolving. This increases the surface area of the solute being dissolved, providing more contact with the solvent.
Okay, so after watching the video, what are the 3 things or factors that affect solvation? You can stop the video and try to answer the question. Okay, welcome back. Thank you for your efforts. So the first thing is stirring or agitation. Yeah. And the second thing is, from the image, surface area. Increasing the surface area increases the rate of solvation. And finally, the last thing is temperature. And increasing the temperature will increase the rate of solvation. Let's have a quick concept check. So try to answer these 2 questions here. Try to fill in the gap in the first one, and in the second one, try to choose one of these 3 answers to put it here. You can stop the video and try your best. Alright, thank you for your efforts. So in the first one, the process of solvation involves solute particles being surrounded by solvent particles. And the second one is the increase in temperature. Yeah, will increase the rate of collision between the solute and solvent, and hence increases the rate of solvation. Since we are still talking about solubility, let's learn a little bit about saturated and unsaturated solutions. We are going to watch the following video and then answer the questions that come after it.
If we add 15 grams of rock salt to 100 grams of water, the salt will dissolve. If we continue adding small portions of salt to the solution, they can still be dissolved. A solution in which yet more solid can be dissolved is called an unsaturated solution. Eventually, when we add another portion of salt, it remains undissolved. We say that the solution has then become saturated. A saturated solution defines the limits to which a given substance can dissolve in a given amount of solvent at a certain temperature.
Alright, so what do we call a solution that contains less dissolved solute for a given temperature and more solute can be dissolved in it? Yeah, we call it unsaturated solution. And what do we call a solution that contains maximum amount of dissolved solute for a given amount of solvent at a specific temperature? True, saturated solution. So far, we have covered 3 main factors that affect solubility or solvation, and these were agitation or stirring, surface area, and temperature. Now, we are going to zoom into the relationship between temperature and solubility. At a certain temperature, solubility can be expressed mathematically as grams of solute over 100 grams of water. So, for example, what does that mean? At 60 degrees Celsius, KCl or potassium chloride has a solubility of 45.8 grams per 100 gram of water. And that means that a maximum of 45.8 grams of potassium chloride can be dissolved fully in 100 grams of water. So let's watch this video and learn more about the relationship between temperature and solubility.
Temperature has a significant effect on solubility. For most solids, solubility increases as the temperature rises. A graph representing the variation of solubility with temperature is called a solubility curve. The curve indicates that at 40 degrees Celsius we can dissolve no more than 40 grams of potassium chloride in 100 grams of water. On the other hand, if we want to dissolve 56 grams of potassium chloride in 100 grams of water, we need to raise the temperature to 100 degrees Celsius.
Alright, so we learned from the video about solubility curves. So this is a solubility curve for multiple substances. And what is the solubility of NaCl at 80 degrees Celsius? So here's the curve for NaCl, the green one. So we are going to go to the 80 degrees Celsius here, go up, keep going up, and then go to the left. So the actual solubility is 40 grams per 100 grams of water, as we have seen in the video. Alright, we have arrived to our first formative assessment, and I would like you to stop the video here, try to answer the following questions, and then continue watching. Alright, welcome back. Thank you very much for your efforts. So let's begin with the first question. At what temperature do potassium iodide and potassium nitrate have the same solubility? So the question is referring to this diagram here, which has the solubility curves of some substances like potassium iodide, potassium nitrate, sodium chloride, and silver nitrate. Alright, so where is potassium iodide and potassium nitrate? So this is potassium iodide, the orange one. Alright, and potassium nitrate is the purple one here. Let me choose a purple color. Alright, so you should find where they intersect. So they intersect here. Can you see? They intersect here. That means they are having the same solubility. So just read the temperature down here. So it's between 80 and 90. Which answer is that? It is 88 Celsius. Yeah, exactly. All right, the second question. At what temperature can 100 grams of water dissolve 210 grams of silver nitrate? All right, where is silver nitrate? Silver nitrate is the blue one here. So we just go a little bit up of the 210, keep going until we reach the curve. What temperature is that? 20, so 20 degrees Celsius. And that's the correct answer. All right, does the solubility increase more rapidly with temperature in case of potassium nitrate or in the case of sodium chloride? So where is potassium nitrate? Potassium nitrate is the purple one, and sodium chloride is the pink one down here. So as you can see, it's increasing more for potassium nitrate. Sodium chloride is just plateauing. There's not much increase. So the correct answer is going to be potassium nitrate. We have reached the ending activity or the plenary activity of part 1, which consists of true or false questions. The first question says that the process of solvation involves solute particles being surrounded by solvent particles. True or false? That is true. One of the main factors that affect solvation of solids is the volume. Is it? No, it's false. Not volume, we can have agitation, temperature, or surface area. Saturated solutions contain less solute than unsaturated solutions. It's actually more, more solute. So this is going to be false. Solubility can be expressed as grams of solute over 100 grams of water. This is true. We are starting Solvation Part 2. The main idea, as a starter activity, I would like you to stop the video and try to think and remember what was the main idea of the lesson on factors affecting solvation. Yes, you are correct. The main idea was that factors such as temperature, pressure, and polarity affect the formation of solutions. In the second part, we are going to continue on solubility, and we are going to study supersaturated solutions, solubility of gases, and finally Henry's law. Now that you know the definition of a saturated solution and how the solubility increases with temperatures for most solids, can you guess what is the definition of a supersaturated solution? So basically, a supersaturated solution contains more dissolved solute than a saturated solution at the same temperature. How can we form a supersaturated solution? The keyword is temperature. So the first step is to prepare a saturated solution at a very, very high temperature. Then cool the solution slowly, cool it down slowly. And then at a lower temperature, more solute is dissolved compared to a saturated solution. And that's how we prepare a supersaturated solution. Until now, we have been discussing the solubility of solids. Let's shift to the solubility of gases. And let's start with the following scenario. When you open a can of sparkling or soda water and leave it for a while, what changes in the taste? What happens to the CO2 gas? Usually, the gas escapes away, right? So, using this question and the table here and the statement that we have down, we want to answer the question of why. The statement says the solubility of gases in water decreases as temperature increases. Why? Again, use the statement or the question that you have up here, the table which contains the solubility of carbon dioxide at different temperatures, and the information from the kinetic molecular theory. Try and find an answer. You can stop the video and come back to it later. Thank you very much for your effort and your thinking. So, the answer to the why question is, at high temperature, the gas molecules move so fast. They move so fast and escape from water. Thus, the solubility decreases because the concentration of the solute decreases inside water. The CO2 or the gas escapes away. That's why at higher temperatures, the solubility of gases decreases. Temperature is not the only factor that affects the solubility of gases. We have also an important factor that is called pressure. So here's an example for you. An example of what happens to CO2 gas when a bottle of Coke is sealed versus when it is opened. So when the bottle is sealed, there's a high pressure of the CO2 gas on the CO2 dissolved in soda. Hence, the CO2 dissolved in soda cannot escape away. And we have another example here of the Coke when it is not sealed. So there is not much pressure above the liquid, okay? And the CO2 dissolved in the Coke is free to escape away. So which one do you think will have higher solubility and which one do you think will have lower solubility? That is correct. So solubility increases when the pressure increases because CO2 cannot escape away, but when the pressure decreases, the solubility decreases. Following from the previous slide, the decreased solubility of the carbon dioxide contained in the beverage after it is opened can be described by Henry's law, which states that the gas pressure is directly proportional to its solubility at a certain temperature. And this is the mathematical representation for Henry's law. S1 over P1 equals S2 over P2, where S represents solubility and P represents pressure, and the solubility is measured by grams per liter. So let's solve an example on Henry's law. 0.85 grams of a gas at 4 atm of pressure dissolves in 1 liter of water at 25 degrees Celsius. How much will dissolve in 1 liter of water at 1 atm of pressure at the same temperature? You can stop the video now, try to answer the question, and then continue. Alright, thank you very much for your efforts. So the first thing we need to do is define the knowns. So we know S1, 0.85 grams per liter, because 0.85 grams is dissolved in 1 liter of water. We have P1, 4 atm, and we have P2, 1 atm. So all we need is to find S2. First step, we write Henry's law. The second step, we solve for the unknown, which is S2. So S2 equals S1 multiplied by P2 over P1. Then we plug in the numbers, and we find that S2 is going to be 0.21 grams per liter. We have reached the plenary activity of our lesson. So please stop the video here, try to answer the following 4 questions, and then resume the video when you finish. Alright, thank you very much for your efforts. So let's begin with the first question. In a glass of sugar water, which substance is the solute? Water, sugar, glass, or none of the above? Of course, it's going to be sugar, and water is the solvent. In the second question, which of the following will not increase the rate of solvation? Agitating the mixture, increasing the surface area, increasing the temperature, formation of a precipitate. We discussed A, B, and C in the lesson, so the answer is going to be formation of a precipitate. The third question says, at a constant temperature, the pressure of carbon dioxide over water increases from 1 atm to 3 atm. If the beginning solubility is 0.878 grams per 100 liter of water, what is the final solubility? Since it's a gas, we are talking about Henry's law, and the final solubility here is S2. So we'll be solving for S2. So S2 is going to be equal to S1 multiplied by P2 over P1. If we plug in the numbers here, we are going to get a solubility of 0.0263 grams per liter. But in the question, they want grams per 100 liter of water. So multiply up by 100 and divide by 100, we get an answer of 2.63 grams per 100 liter of water. Finally, sucrose dissolves in water because it's an ionic compound? No, it is a covalent compound. Both water and sucrose are polar molecules. Both water and sucrose are molecular compounds. Both water and sucrose have high melting points, and the correct answer is B. And you remember, like dissolves the like. Both are polar. Here's a recap of what we covered in part 1 and part 2. We covered that the process of solvation involves solute particles being surrounded by solvent particles. We also covered that solutions can be unsaturated, saturated, or supersaturated solutions. Finally, we have covered Henry's law, which states that at a given temperature, the solubility of a gas in a liquid is directly proportional to the pressure of the gas above the liquid, and we solved an example using the mathematical relationship of Henry's law.